So in this video, let us discuss about echelon form of a matrix, and also let us learn how to find rank of a matrix. So a matrix A is said to be in echelon form if it satisfies the following conditions. First, let me write the example, then it will be very easy to understand these statements. Let us consider a matrix that is 0, 2, 3, 5, 0, 0, 3, 2, 0, 0, 0, 0. So this is a matrix. Now actually this is an example of a echelon form of a matrix. Now by looking at this, what you understand? See the first point. All the zeros, if any, must be present at the bottom of the matrix. It is not necessary that all rows should be 0 at the bottom. Not necessary. If at all zeros are present, then it should be present at the bottom. That's what first condition says. And see the second condition. Number of zeros before the first non-zero element in each row must be less than that of such zeros in the succeeding rows. Now you see here in the first row there is only one zero before the first non-zero digit. So in the second one it should be one more than that. That is two zeros before the first non-zero digit. First non-zero digit here is 3. So before that there are two zeros. So in the last one, all zeros. It can be 3 zeros also. The fourth one can be some number. So once you write the given matrix in echelon form, then it is very easy for us to find the rank of a matrix. Now how to find rank of a matrix? Rank of a matrix, if you want to find, you have to first find out how many non-zero rows are present. Non-zero rows. So this is also non-zero, but this is 0. So how many non-zero rows are present? That will determine the rank of a matrix. So here in this example, rank of a matrix A is equal to 2 because there are 2 non-zero rows. Let me explain some more example here. Now you consider a matrix B. So matrix B, here it is 1, 2, 3. Here let me consider 0, 5, 7. Now is this an echelon form? Definitely yes. Because in the first row you see there are no zeros only. It is not necessary to have zeros. Whereas in the second row you see there is 1 0 before the first non-zero digit. So this is also an echelon form of a matrix only. So here what is the rank? You see here this is the non-zero row. This is also the non-zero row. Therefore rank of a matrix B, this is how we write. Rank of a matrix B is equal to number of non-zero rows. Since the number of non-zeros are 2 here, so the rank of this matrix is 2. Let us consider some more example so that you will understand clearly. Now one more example let me take. This is C, matrix C. So matrix C here is 1, 2, 3, 4. Here 0, 1, 3, 4. Next one 0, 0, 2, 3. So now you tell me what is the rank here? How many non-zero rows there are? How many non-zero rows? See, this is a non-zero row. This is another non-zero. This is another non-zero. Therefore, rank of a matrix. This is echelon form only. So first you have to reduce it to the echelon form. Once it is reduced to the echelon form, then you count how many non-zero rows. So rank of matrix C is equal to 3 because there are 3 non-zero rows. Now one more example. Let us consider it as matrix D. So here this is 0, 1, 2, 3. This is 0, 0, 1, 2, 0, 0, 0, 0. Is this an echelon form? Yes, this is also an echelon form. Here you see the first row. This is a non-zero only. This is a non-zero. Zero row means all should be 0. So in this you see third row is 0. Therefore, what is the rank of this matrix D? Rank of this matrix D is 2. So I hope with these examples it is clear how to find the rank of a matrix once you write the given matrix in echelon form. Let us work out two problems here. Now let me write the question. You are asked to find the rank of the matrix. Find the rank of a matrix A. A is equal to 1, 3, 5, 2, minus 1, 4, minus 2, 8, 2. So this is a given matrix. Now how to solve this? Solution. Now how to solve this? Now what you have to do is you have to reduce the given matrix into echelon form. So reduce the given matrix to echelon form. In a single step it is not possible. Now you see in this example, this is first row R1, this is R2, this is R3. Okay, so that we are naming it like that. So first what we will do is, let us see that this 2, see first row don't disturb. In the echelon form, if there are no zeros in the first row, no problem. So let us not disturb it. Now you have to see that in the second row, the first element is 2. So you see that becomes 0. Remaining 2 in the same row, you don't worry. Whatever you get, whatever rule you apply for the that 2, number 2 there, the same thing will continue for other 2 also. So what we need to do is, if you want to make it as 0, you have to consider this with either row 3 or row 1. So let us make it with row 1. So if you want to make that 2 as 0, you should have row 2 operation with the row 1. So how to make that 2 0? It has to be 2 minus 2 as 0. So now what to do? You see that this becomes this one becomes 2. So how can this one become 2? So we can write this as a general rule here. R2 becomes R2 minus 2R1. So what happens here? You see R2 becomes R2 is 2 there, right? 2 minus 2 into R1 is 1 there. Okay, this is 1. So what happens here? 2 minus 2, that becomes 0. But it is not only applicable for that 2 remaining there. Minus 1 and 4 also should be done with the same type of operations. For the entire row you have to operate. So here what happens? Minus 1 minus 2 into, what is R1 there? R1 is 3, right? So you get this as minus 7. Same way, one more you have there, that is 4. So R2 is 4 minus 2 into R1. What is R1 there? That is 5. So you get this as minus 6. Okay. So in the same way, in the same step itself, you can go for reducing the R3 also. So how to make R3? You have to see that again, the same rule. You see that this becomes 0. This minus 2 becomes 0. Now you see there R2 and R3. How to make that R3 0, minus 2 0? So minus 2 plus 2 will give you 0. Okay. So you solve the relation. You have to write an equation for R3 with respect to R2. So R3 becomes R3 plus R2. So what happens now? R3 becomes minus 2 plus 2. R2 is 2, right? So minus 2 plus 2 becomes 0. In the same way, the same rule has to be applied to other two elements also. So 8 minus 1. Actually it is plus, because of the minus 1 it becomes minus there. So 8 minus 1 is 7. One more you get there, that is 2. 2 plus 4. 2 plus 4 is 6. So now what happens to the matrix? Now the given matrix becomes first one, there is no change, 1 3 5. Now second one, what happened? It is 0 minus 7 minus 6. And what happens to R3? R3 is 0 7 6. Now whether this matrix what we obtain now is in echelon form? No. First row is okay, second row is okay, but third is not okay, because the number of zeros in the second row and third row is same. It cannot be same. In the third row at least one more should be there. So now what we will do, you solve for the third one. Second one you don't disturb. You have to see that here, you have to see that this is 7, this 7 becomes 0. How the 7 can be made 0? You add 7 minus 7, right? So you consider this R2 and R3. Now this is R2, this is R3. Now you solve between R2 and R3. The easiest way to solve this is addition here. So R3 becomes R3 plus R2. That is R3 becomes, first one you see there is no change. Even if you don't write also no problem. 0 plus 0 is 0 only. So this is R3 becomes 7 plus minus 7, that is 0. The last one, R3 becomes 6 plus minus 6, it is 0. Therefore, what happens to the matrix now? This is 1 3 5. Second one we did not do anything, so same thing we would write 0 minus 7 minus 6. Last one, what happened? All rows we got it as 0. Now you see this is in echelon form. What did echelon form say? If at all zeros, zeros are existing, it should be at the bottom, that is fulfilled. And you see, if there are no zeros before the first non-zero digit in the first row, that is fine. But in the second one, you see first non-zero digit is minus 7, before that at least 1 0 is there. So now how many non-zero rows here? Now this matrix is in echelon form because it fulfills the condition, right? It fulfills the condition. So now what happens? You see here, this is non-zero, this is non-zero, last one is 0. Therefore rank of a matrix A is equal to 2. Okay, so this is A only, this is A. Okay, so you get this as 2. Now one more problem we will solve. One more problem. Find the rank of a matrix A equal to 1 2 3 minus 4 0 5. So here this is R1, this is R2. Now, since there are only 2 rows here, it becomes very easy. Now, how to solve this? How to solve this? You have to write this matrix in echelon form. So, reduce this. Reduce the given matrix into echelon form. So, what is the first step? You have to see that this minus 4 has to be made 0. This minus 4 should be made 0. So how to make it 0? You have to write a relation between minus 4 and 1, so that when you do the operation it becomes 0. So what is the method? Here this R2 has to be written as R2 plus 4 times R1. Now why you have to write this as 4 times R1? Because this 1, if it is 4, then you see minus 4 plus 4 will give you 0. So how to do that? R2 becomes minus 4 plus 4 into 1. Now you see minus 4 plus 1 is 0, right? But in the same way, R2 is equal to 0 plus 4 into 2. That is, you get it as 8. R3 gives 5 plus 4 into 3. That is, you get it as 17. Now what happens to the equation? Now you rewrite the equation. Equation A is, first one we have not disturbed, right? 1, 2, 3. Here this becomes 0, 8, 17. Now is this echelon form? Yes, it is echelon form. Why? Because in the first row there are no zeros. But in the second row, before the first digit, there is 1 0. That is sufficient. So how many non-zero rows are here? This is non-zero. This is also non-zero. Therefore, the rank of a matrix A is 2. Because there are 2 non-zero rows. I hope this is clear. So like this, any given matrix, your target is to reduce it to the echelon form. Once it is reduced to echelon form, don't further go for reduction. Not needed. Okay. So thank you for watching this video.